All right, so let's continue with our discussion of simplifying rational functions. And there's just a couple steps that we're going to do every single time. And the first one is going to be to factor. When you're dealing with rational functions, the first thing you want to do is factor, because when you factor, you can identify wholes or asymptotes, which is useful for graphing, but your wholes and your asymptotes are also domain restrictions. And this is a good time to write down those domain restrictions, just to immediately jot down, oh, x can't be these numbers. So let's look at an example. Example number 1, x squared plus 6x plus 9 over x squared minus 9. Now, if you're super clever, you're going to notice that this is a perfect square. I've got u equals x, I've got v equals 3, and 2 times 3 times x is 6x. So this becomes x plus 3 times x plus 3. And yes, I could write it as x plus 3 squared, but I'm not going to for reasons that are about to become obvious. Oh, hey, look, a difference of squares. I've got on the bottom u equals x and v equals 3, which means that this is x plus 3 times x minus 3. So let's identify wholes. First thing I see is that I've got a hole right there. That's equal to 1. Big giant 1. But at this point, so that I don't forget later, I'm going to jot down that x cannot be equal to 3 and x cannot be equal to negative 3. I have a hole at negative 3, and what I discover is that, in fact, this simplifies to x plus 3, over x minus 3, so long as x is not equal to plus or minus 3. That's my simplification, and I've got a hole there at negative 3, and I've got an asymptote at x equals positive 3. All right, let's do another example. Example number 2. 2x squared minus x minus 10 all over 3x squared plus 7x plus 2. So step 1, always step 1, factor. What have I got? I got 2x, I got x. I'm going to say probably 5 and 2. Yep, because 2 times 2 is 4, 5 times 1 is 5. I want the 5 to be negative and the 4 to be positive. And on the bottom, I've got 3x and x, and my only choices are 1 and 2, and I want 7, so I'm going to need 2 3s and 1 1 to make 7. And immediately, again, what do I notice? Hey, look at that. I've got a big giant 1 right there, which means I have a hole at x equals negative 2. And looking at the other term, I've got an asymptote at x equals negative 1/3. And this simplifies to 2x minus 5 over 3x plus 1, so long as x is not equal to negative 2 or negative 1/3. All right. Quick example 3. I think I might be running out of time here, but let's take a quick look. 28x squared minus x minus 15 divided by 28x squared minus x minus 15. Now, what you might say is, hey, this equals 1. Well, true, but I still need to factor because I still need to know what values of x this does not work for. And when I factor this, I get 7x plus 5, 4x minus 3, 7x plus 5, 4x minus 3, and I can immediately see that I have 2 holes in this. This is going to be a horizontal graph with a hole at 3/4 and a hole at negative